Part 2 of Pre-Calculus Semester 1 exam review. Number 10. Given f of x equals x squared minus 2 and g of x equals 2x plus 4, find f plus g of 6. This simply means find f of 6 and add it to g of 6. So I'm going to plug 6 in everywhere I see an x in both f and g. So when I find f of 6, it ends up equaling 6 squared minus 2, which is 34. So I'm going to replace f of 6 with 34. I need to find g of 6. When I plug 6 in, the absolute value of 2 times 6 plus 4. Again, sorry for the sloppy writing. It's very hard to write on this iPad. That's 2 times 6 plus 4, which is 16. I replace g of 6 with 16, and you end up with 50 as your answer. Number 11. What is the range of f of x equals the absolute value x minus 4? So range talks about the y values. What y values get used in this graph? Well, we have to identify the parent function, which is simply the absolute value of x. And if you remember what that looks like, it's a v. I'm going to write this down here, and it starts at the origin, okay? So there's my absolute value graph. I have to determine what this minus 4 does in the equation. The minus 4 is with the x's. So the minus 4 does the opposite because x's are stupid, so it does not move left 4, it actually moves right 4. So if I move this 4 to the right, here is what my new graph looks like, the blue one. So when I ask myself, if I start walking at the bottom of the y-axis and start walking up, which is the first y value I would hit? So when I'm down here, if I look left or right, I don't see my graph. The first place I would run into my graph would be right here when y is 0. So the range would be from 0, and if I keep walking, see now when I look left or right, I would see the graph. And if I keep walking, I'd see it all the way up to infinity. Infinity always has an open parentheses. And because I can use 0, I put a closed bracket around it. Number 12. Describe the translation from f of x equals the square root of x to g of x equals the square root of negative x minus 4. So we have several things going on here. First, let's look at this minus 4. It's not underneath the square root with x, so it doesn't affect the x values, it affects the y values. So it simply moves me down 4. We also have a negative in front of x, okay? What that does is it reflects my graph. Since it's inside with x, it changes the x values, which means it gets reflected over the y-axis. Reflected over the y-axis. So if I had to describe the translation, I would say it's down 4 and flipped or reflected over the y-axis. And let me explain why it's the y-axis again. So the negative is inside with x, which means it changes my x values. So if you think about it, if I had the value 4, now it becomes negative 4 on the left side of the graph. So I flipped over the y-axis. Okay. Number 13 says factor 3x squared plus 3x to the third plus 12x squared minus 15x. Whenever you factor, you always look for a GCF, the greatest common factor. I can divide a 3 out of each of these, and I can take an x out of each of these. So 3 divided by 3 leaves me with 1. If I had x to the third and I took 1 away, I'm left with x squared. The next term, 12 divided by 3 is 4. If I had x squared and I took 1 away, I only have 1x left. Negative 15 divided by 3 is negative 5. If I had an x and I took it away, I no longer have an x value there. Now, I have to factor what's inside the parentheses. So I'm just going to keep the 3x outside at all times. Okay? And my goal is to factor it into two binomials. Since there's no a value in front of x squared, I just looked at c. And the only factors of 5 are 1 and 5. So I know I have to use 1 and 5. I use the rule, the sign of b goes with the big number. So this goes with the big number. So my 5 has to be positive. Now, positive 5 times what will give me a negative 5? We know it's 1. But a positive would have to be multiplied by a negative to give me this negative in the back. Okay? So it's going to be x minus 1, and x plus 5. And I just brought these down like this. Some of you may use the box method here. That's fine. If you forget to factor out the greatest common factor, that becomes a much more difficult problem. So always look for that first. I am about to go to the next page. Please pause it if you need to write anything down. Okay, I just want to make sure we are on 13. I'm missing a page. Hold on, I'll be right back. Okay, here we go. So for number 14, it says, for the function graphed above, approximate the relative minimum. Okay, so the minimum, and I'm going to trace this graph for you because it's a little hard to see in this picture. Remember, a relative minimum isn't the lowest point on a graph. It's the lowest point in an area. So if I had to locate the relative minimum, I would say right here. So those are your little hills, the bottom of the hills or the top of the hills. And if I had to estimate where that's at, and again, it's very hard to draw on here. If I had to estimate that, I would say it's at about -1. Let's do that again. Hold on one second, guys. Yeah, that's not going to let me do it, I don't think. There we go. That's a little bit better. So the minimum would be at -1, because I went left, and up 5, and that's the bottom of a hill. A maximum would be a top of the hill. State the intervals where the above function is increasing. Increasing means as I go from left to right on my graph, I'm going up. So if I'm following here, I am not going up left to right, I'm actually going down. Let's try the next interval. From here to here, sorry guys, from here to here, I know that's hard to see, but from -1 to my maximum, my local maximum, which occurs at about 1, I am going up. I'm increasing, and I'm going to highlight that in blue here, or draw it in blue because it's hard to see. So from -1 to about 1 right there, my graph goes up as I move from left to right. If I go and look at the next interval, you can see as I go left to right, I'm going down. So that would be decreasing. So the yellow and red pieces would be decreasing because as I move from left to right, they're going down. They didn't ask for that. They asked for increasing, which was that middle piece. How many zeros are there on the graph above? Hopefully you remember that a 0 is where your graph crosses the x-axis. And that only happens at one point. So there is 1 0. Okay, so that's the end of part 2 for the final exam semester review.